Hey guys, Matt Marzillo here. This is our last example for the week with using the financial functions. And we're moving from the payment function to the future value function. And you can see I have the syntax of the future value function sitting right here in cells C8 and H8. And future values function is a good tool to use when you're trying to calculate the end value of a regular investment, right? So let's say you're contributing $300 every month to a savings account. You know that savings account's going to grow 3% a year. You want to know in X number of years how much money you'll have based on that. And the future value amount will calculate that for you. And what we have here is we have two separate questions, right? So if you look up here, we have assuming a 3% return rate, what will the future value of an account be if $300 is contributed each month over 5 years? So that's the rate of 3%, the number of years is 5, and our monthly contribution is $300. The second question is similar assumptions, 3% return rate, and we're looking for the future value of an account in 5 years, but we're making $0 of a monthly contribution, and we're just putting $18,000 in it right away, right off the bat. So at the end of the day, we're contributing the same amount of money, right? Because $300 times 12 times 5 is $18,000. But we're contributing this over the course of time, and we're just dumping this $18,000 in the account from the get-go and leaving it alone. The future value, or the FV function, is the perfect tool for us to answer this question. So let's go ahead and start with the first question. So we're in cell B8, and we're going to handle this the same way we handle the payment function. We're going to go up to the insert function tool here, this wizard. We're going to go to all, right, not most recently used, all, and search for FV. We're going to click go, and there FV is sitting right up there at the top. Okay, highlight that, click OK, and now we just got to plop in our arguments here, right? So our rate is 3%, but since we're using a monthly contribution, we want to make sure that we're putting that in a monthly rate. So we divide B4 by 12. We have the number of periods is 5, but we're using monthly, so we want to multiply that out by 12 to give us the number of months, keeping everything consistent. And the monthly contribution is $300 in cell B6, and our present value is 0. We're starting off at 0, right? So if we click OK, what this is telling us, and it's automatically going to give us the negative number. So let's make that absolute, since that makes more sense for this application. Type in absolute. Okay, see how I did that in the previous example, where we're kind of wrapping this FV function around an absolute function to make sure the number is positive. Well, so what that's telling us is that, over the course of 5 years, we're going to put in $300 a month, and our end state, or future value, is going to be about $19,400. So that's not bad. We put in $18,000, we wind up being about $1,400 up. That's great. But let's take a look. Let's say we have $18,000 just sitting around that we want to put in an account rather than kind of paying it in monthly. Let's take a look how the interest will accumulate on that account as opposed to paying it monthly. So again, let's highlight cell G8. Head up to the function, insert function here. Highlight FV, click OK. And this time what we're going to do is we don't really need to make it monthly, right? We're not making any payments. We're going to just put in the rate of 3%, the number of periods of 5 years. Our payment is 0, right? Since we're just putting in $18,000. We're going to type in 18,000 right here as our present value. And then we're going to click OK. Okay, so it's showing us almost $21,000. Let's make that absolute again. Click up here just after the equal sign. ABS, open paren, close the paren. Okay, so what that's telling us is that if we just put $18,000 right from the get-go, we're going to end up with about $21,000, and that makes sense, right? You have a good chunk of money sitting in there from day one that the interest is going to accumulate on, as opposed to that base amount or that principal amount kind of growing over time, right? And it kind of makes sense. There's less money in example one for the interest to grow upon. Okay, so that's a simple example of how to use the future value function in Microsoft Excel. Kind of similar principles of payment function, just kind of another way to look at similar problems. Okay, guys, as always, any questions, feel free to give me a call or shoot me an email. Thanks a lot.